Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson number 12, sound. Now if you all remember, in part 1 for the lesson sound, I gave you all the basic terminologies where we discussed on what is time period, wavelength, frequency, what is a wave, right? Then we discussed on two different types of waves that exist. That is about the longitudinal wave and the transverse wave, and the basic difference that exists between this transverse wave and longitudinal wave is transverse wave is going to be perpendicular, right? It is like the wave is going to be perpendicular in the direction, right? And longitudinal wave is going to be parallel, right? So this is the only difference like that we discussed with respect to transverse wave and longitudinal wave, and there were other some of the terms that we had discussed along with all this, right? So before I proceed with this part, that is part 2 of the lesson sound, where we are going to start with the exact part. Now you know already, I've even introduced the lesson to you. Now you are friend to the lesson, right? You have to know about each other now. Okay, so you will have to know more about sound, what it is, what does it likes, where it is used, what it doesn't like. Okay, and you can consider the terms frequency, time period, them like as the relatives of the sound. So you're even going to know the relatives of the sound. Okay, so make sure that you are smiling and learning the lesson so that like you understand the lesson properly. I don't want any one of you to be stressed and like study the lesson. Every lesson that you have in your book is very easy. Okay, and the way that we are doing it with continuous revision and everything is going to make it more easier for you if you follow the things that have been said during the sessions. Okay, so now before I proceed with this part 2 of sound, I want each one of you to please revise each and everything that you have taken in your book in the last session. I hope every one of you have started the revision part. See, you have to revise each and everything that we have studied so far. Okay? So you have to go through each and every term and you should be knowing the terms very properly. Okay? So now I'm going to start with the lesson. Okay? The exact lesson, that is sound. So make sure you are like taking the lesson as like the easiest one in your mind, because if you think that it's the hardest lesson, you're going to learn this, learn that, everything. So please don't have that in your mind. Okay? See, now the first topic that we have under this lesson is production of sound. Okay, what do we have in this lesson? Production of sound. So see, sound is produced due to the vibrations of the object. And let me tell you one interesting fact about sound. Like if there is no vibration, if there's no vibration, sound won't be produced. Okay. So sound is produced due to vibration of object, and when we are speaking as well, our larynx, which is also called as the voice box, that vibrates, because of which the sound has been produced. So whatever I'm saying or whatever you are able to talk is all because of the vibration of your voice box. So the first statement, I hope is very much clear to everyone, that sound is produced due to the vibration of objects. So if you find out now, I want you all to actually observe the things around you. Like whichever object produces sound around you, just have a quick glance through it and you'll find out that it's the vibration because of which like the sound has been produced. And if there is no vibration that has been produced, so if no vibration, no sound. So vibration plays a very important role in production of sound. Okay. So now what exactly vibration is? How can we define vibration? You can even get a question like, what is vibration? A basic, you can say 1 mark question. Okay. So vibration is the rapid to and fro motion of an object. What is vibration? It's the rapid to and fro motion of an object. So whenever you have been asked what happens in vibration exactly, there's going to be an to and fro motion of an object which is going to take place, and this motion is always going to be very rapid. So vibration is the rapid to and fro motion. To and fro means aage piche, okay? So to and fro motion of an object. And for example, the sound of human voice is produced due to the vibration of the vocal cords. Now, why we are able to produce sound? So, our human voice is produced, the sound that has been produced by us is because of the vibration that occurs in the vocal cord, that is in the larynx or the voice box that we have. Okay, so we have an example that has been given over here. A stretched rubber band when plugged vibrates and produces sound. Now, like, I hope most of you might be having a rubber band with you all, right? So please go and take that rubber band and see. You will find out that when you stretch that rubber band and once you leave it, what happens? It is going to get like, it is going to vibrate, and after vibrating it's going to produce a sound. Okay. Okay, so I hope every one of you have performed this. Now see, we have an activity to discuss. Strike the prongs of a tuning fork on a rubber pad and bring it near the ears. Okay, so can you see the prong in the picture? That is called as a tuning fork. What you need to do is, you need to strike that. Okay, strike it on a rubber pad, and you have to bring that near to your ears so that you can listen to the sound that has been produced. Okay, so if a suspended table tennis ball is touched with the vibrating prong, the ball is pushed away repeatedly. If you do this, like if you take a table tennis ball and if you touch that with this vibrating prongs, you will see that the ball will be pushed away repeatedly, and this shows that the prong is vibrating and the vibrating object produces sound. Okay, so it's like all the vibrating objects are going to produce sound. Okay, and if there's no vibration, then no sound will be produced. Okay, so I want you all to please write like all the important points, and you can even draw the table turners and the tuning fork, how the vibrations have been seen. Please write all the important points from this slide for production of sound. I hope you all are writing all the important points from the screen. I hope every one of you are done writing with this. Now after this, the next thing after like discussing the production of sound, the next step is propagation of the sound. You know, sound needs a medium to propagate. So like we will be discussing on propagation of sound over here in detail. So see, the sound produced by a vibrating object travels through a medium to a listener. So when I'm talking to you, there's a medium because of which the sound, whatever sound has been produced by my vocal cords are getting like is audible to you, right? And over here, the medium either can be a solid, a liquid, or gas. Like we cannot confirm it. Medium can be solid, liquid, or gas. Okay. So when an object vibrates, the particle around the medium will vibrate. Okay, because we just studied that if there is vibration, then only the sound will be audible. If the vibration is not been produced, sound won't be produced, right? So if when an object is vibrating, the particles along the medium, around the medium is also going to vibrate. So whatever particles are going to be in contact with the vibrating object, it is first displaced from its equilibrium position. Displaced means because it's moving, right? When an object is vibrating, the medium is vibrating, and whatever particles will be contacting the vibrating object, what will happen to those vibrating objects? They are going to get displaced from its equilibrium position. Okay. After that, it then exerts a force on the adjacent particle, and the adjacent particle is displaced from its position of rest. What will happen? This displaced particle is going to exert a force on the adjacent particle. Now, adjacent particle means the particle which got vibrated. There are some more particles just beside that, right? So, that vibrated particle is going to exert some, you can say, is going to exert some force on the adjacent particle, because of which it is going to get displaced from its position of rest. So the adjacent particles are also getting displaced, and after displacing the adjacent particle, the first particle comes back to its original process. So what happened? The particle which was beside the vibrating particle, it got displaced, and the first particle again came back to its original position. So this process is going to repeat in a medium till the sound is reaching our ear. Okay, because the main motto of propagating the sound is so that it's audible to our ears, right? So it's all because of the displacement that is taking place over here, and because of the object which gets vibrated. So vibration is one important thing, and propagation of sound through a medium. See, a medium is very important part for you to listen to any kind of sound, and this medium can be anything. It can be a solid medium, it can be a liquid medium, or it can either be a gaseous medium. Okay, it doesn't matter which medium it is, sound just needs a medium to propagate. So if there is no medium, the sound won't propagate and it won't be audible to us. Okay, so this is how the sound is reaching our ears, and the disturbance produced by the vibrating body travels through the medium, but the particles do not move forward themselves. Now, what is happening? The particle which vibrated is going to displace the adjacent particle, right? What will, and then the first particle will come back to its original position, right? So the disturbance that has been produced over here by the vibrating body is going to travel through the medium, but whatever particles will be there, they are not going to move forward themselves. Okay, so they are not moving there like by themselves. There is a wave. So that wave, like we have already discussed this definition of wave in the last class, if you all remember. How can we define wave? A wave is a disturbance which moves through a medium by the vibration of the particles of the medium. What is a wave? Wave is a disturbance which moves through a medium by the vibration of particle of the medium. The particles are vibrating, so there is a wave which has been created over there, and that wave is regarded to be a disturbance over here, because of which the particles which are vibrating, they are moving ahead. Okay, so sound is considered as a wave. So we have sound waves which have been produced due to vibration of the particles of the medium, and these sound waves are called mechanical waves. So if you remember, in the last class we have discussed on two types of mechanical waves, transverse wave and longitudinal wave, right? These were the two mechanical waves that we have discussed. So you need to know that sound is considered as a wave, and this sound wave, they are being produced because of the vibration of the particles of the medium. Okay, and because there are vibrations and the waves which have been generated, these sound waves are called mechanical wave. What are they called? They are called as mechanical waves. Okay, so now I want you all to write all the importance from this important points from this slide. There are many points over here which are important. Okay, so please write them all. I hope every one of you are writing it. So you need to write all the important points from the screen. Okay. After this, like, I hope you all have written all the points you have written about that. The sound produced by vibrating object travels through a medium to a listener, right? And this medium can either be solid, liquid, or a gas. And whenever the object is going to vibrate, the particles of the medium vibrate as well. And whatever particles are in contact with the vibrating object, they are going to displace the adjacent particle, because of which the first particle will come back to its original position, right? And this is how the sound is like audible to you, right? After this, we have to study about the propagation of sound through air. So, you know that air is considered to be the most common medium through which the sound travels, because we know that air is present everywhere around us, right? So, that is one of the reasons that we say that it is one of the common medium through which sound travels, right? So when a vibrating object moves forward, it pushes and compresses the air in front of it, forming a region of high pressure called compression. Now, if you remember in the last class, like while I was giving you the definitions for different words, right? There were many terms where I said you all that there is compression and rarefaction that takes place, right? So over here we are going to discuss on compression and rarefaction. Okay. So whenever a vibrating object is going to move forward, it's going to push and compress the air in front of it, because of which a high pressure will be created in that region. Okay, and we call that as compression. So compression moves away from the vibrating object. What happens? Compression is going to like take the vibrating object away. So always the compression is going to move away from the vibrating object, and when the vibrating object moves backward, it forms a region of low pressure, and that region of low pressure, we know it as rarefaction. So we have two terms, compression and rarefaction. You have to know this, okay? So if you can see CR, like a barcode kind of thing on screen, I'll show you. Can you see this? How compression is and how rarefaction is. So like compression is going to be like this. There will be very minute, small distances in between. This is compression and this is rarefaction. Okay, so if you can see, this is all rarefaction. Over here, this is compression. This is rarefaction. Compression. Sorry, rarefaction, compression, rarefaction. So this is how sound has been produced. So there is going to be one compression, then rarefaction. Compression, rarefaction. This is how it's going to happen. Now what's compression? Just see the definition for compression again. When a vibrating object moves forward, it pushes and compresses the air in front of it, forming a region of high pressure. So because the pressure in this region is going to be high, and because the air has been compressed in the region, it is called as compression. So compression is going to move away from the vibrating object. And the next thing that we have is rarefaction. So when the vibrating object moves backward, in compression the vibrating object was moving forward. In rarefaction, the vibrating object moves backward. So, and see, there are three basic differences that you can see over here. The vibrating object is moving forward in compression. In rarefaction, it moves backward. Okay, then for compression, we have a region of high pressure that has been created, and for rarefaction, a region of low pressure has been created. So this is the basic difference that you need to know between compression and rarefaction. And as I already shown you, right, how exactly the tones, like the waves or the sound wave, is going to look like when you hit that, right? So as the object is going to move to and fro rapidly, now the movement which takes place to and fro rapidly, we know it as vibration. So it means as the object vibrates, it produces a series of compression and rarefaction in the air, which makes the sound to propagate in the medium. So this is how, like, if you are being told to draw for compression, you need to draw it where you will find out that it will have high pressure under it, and this is going to be near. The waves are going to be very much close to each other. Whereas in rarefaction, because there is low pressure, the waves formed will be far away from each other like this. So this is compression and this is rarefaction. Okay. So I hope you all have understood this, how exactly propagation of sound through air takes place. Now I want y'all to please write all the important points from this slide. Propagation of sound through air. I hope you all are writing all the points from the screen. I hope you all are writing from this screen. You need to know about compression and rarefaction, what exactly they are, the definition for them, and you need to even mention the first point that air is the most common medium through which the sound travels. Okay. I hope you all have written all the important points from the screen till now. Now see how a vibrating object producing a series of the sound where we have continuous compression and rarefaction that has been given, right? So can you see compression? Then there's a rarefaction. Like when you vibrate this tongue, you will see that there will be continuous compression and rarefaction which can be seen, right? As you can see it over here, same thing has been shown. So I want you all to please go through it. You need to draw this, okay? Now after this, the next point that we have is Sound needs a medium to travel. Okay, now as we already discussed in the last class, that sound needs a medium to travel, and the medium can either be a solid, a liquid, or a gas, right? But it needs a medium to travel. So sound is a mechanical wave and it needs a medium for its propagation. And for that, it can travel through solid, liquid, or gas. It can travel through all three. Okay, that is solid, liquid, or gas. And sound doesn't travel in vacuum. Now this is a very important point to highlight in your book, that sound does not travel in vacuum. You should be knowing this. Okay, so I want you to write this thing in your book, that like you have already written that sound travels through solid, liquid, and gas, but just include this point as well, that sound does not travel in vacuum, which is an important point again. After this, we have an activity to discuss over here. See, suspend an electric bell in an airtight bell jar and connect the bell jar to a vacuum pump. If the switch is pressed, we can hear the sound of the bell. Okay, what they stated, that if the, like when you connect the bell jar to the vacuum pump, okay, if you press the switch on, in that case you will be able to like listen to the sound of the bell. And if air is pumped out through the vacuum, we cannot hear the sound of the bell. And this shows that sound needs a medium to travel and cannot travel in a vacuum. So once we perform this activity, we can conclude that sound needs a medium to travel and it cannot travel in vacuum. Okay. So I hope you all are explaining the activity in your own words. Oh, sorry. I hope you all are writing it in your book, everyone. After this, we have the fourth point as sound waves are longitudinal waves. So, see, sound propagates in a medium as a series of compression and rarefaction, right? Now you know this, that there will be series, like once it will be compression, then rarefaction, compression and then rarefaction, right? This is how it's going to work. So in this waves, the particles move back and forth parallel to the direction of the propagation of the disturbance. How the particles are going to move? They're going to move back and forth, and this back and forth movement is going to be parallel to the direction of propagation. Okay, so such waves we call them as longitudinal wave, and transverse wave is going to be perpendicular. We have already discussed this in the last part, right? That there is another kind of wave which we know it as transverse wave, and in this waves the particles oscillate up and down perpendicular to the propagation of the direction of the disturbance, right? So in longitudinal wave it's going to be parallel to the direction, and in transverse wave it's going to be perpendicular to it, right? I hope you all are writing all the points. Like you need to write what exactly transverse wave is and what is longitudinal wave as well. Okay. So now see here we have an activity that is with respect to slinky. So slinky is like pen के अंदर जो होता है जिसको we can stretch it, right? We can pull it. So stretch a slinky and push and pull it alternately at one end. Okay, so you'll take that slinky and you have to push and pull that slinky alternately. And after that, if you mark a dot on the slinky, the dot moves back and forth parallel to the direction of the propagation of the disturbance. So can you see the figure B, A and B, where in the A figure you are stretching the slinky, and in the B figure you can see the continuous you can say compression and rarefaction, right? And lastly, now like the last topic for today we'll be discussing is characteristics of the sound wave. But I hope like you all have gone through it. Okay. See, now the last topic for today that we will be discussing on is the characteristics of a sound wave. See, sound wave can be described by its frequency, amplitude, and speed. Now, if I would have started this part, like I would have like just started this part like this without introducing you the part, you would not be aware of frequency, amplitude, and speed, right? But now you have the definition with you on amplitude, frequency, and speed. So I want you all to please go through the definition first and then I'll move forward. I hope you all are going through the definition of frequency, amplitude, and speed. Okay, are you all going through the definition of frequency, amplitude, and speed that you took in the last class? Please go through the definitions properly. Okay, So now, as they have stated, that sound wave can be described by its frequency, amplitude and speed, and we can graphically even represent sound as a wave, because we know that we have like sound wave which also act as mechanical wave, right? And we just now studied about the two mechanical waves. One is transverse wave and the other one is the longitudinal wave, where there is a difference of perpendicular, like there's a difference of the direction. One is perpendicular and the other one is parallel, right? So we can graphically represent the sound as wave, right? And there is changes in the density and pressure as sound moves in a medium. In whichever medium the sound is going to move, there's always going to be change in the density and pressure of sound. So always remember this point, that as and when the waves have been created, the density and the pressure of the sound is going to change in the medium. Okay, so compressions are the regions of high pressure and density, where you will see that the particles are crowded, and there will be upper portions of the curve which is called as crest, and the lower portions are called as trough. So high pressure areas are called as crest and low pressure areas are called as trough. I'll show you how exactly it looks like. Okay, I'll show you what exactly it is. So this is the crest where there is high pressure, and this is the trough. Okay, so compressions, what are compressions? They are region of low pressure, high pressure and density, where the particles will be crowded, and we represent them as the upper portion of the curve, and we call them as crests. And rarefactions are the region of low pressure and density, where you will see that the particles will be spread out, and we can represent them by lower portion of the curve, and we call that lower portion of the curve as trough. Okay, so we have a crest and we have a trough. So the distance between two consecutive compression or two consecutive trough is called wavelength. Okay, so distance between two compressions or two trough, like rarefaction, you can say crest or trough, we call that as wavelength, and we represent by the symbol that is like a Greek letter which we know it as lambda, and its SI unit is meter. So the distance is represented by wavelength, which is represented by this Greek letter lambda, and the SI unit of wavelength is meter. Now on this slide we have the definition of the crest, we have the definition of the trough, and we have the definition of the wavelength as well as the SI unit of it, right? So I want each one of you to please write that in your book. You can even draw this crest and trough that I have shown you for your understanding, so that you know what exactly I'm talking about. I hope every one of you are writing all the important points from the screen. I'm giving you one last minute for it, so please write this, everyone. Okay, so I hope you all are done writing this much. Now in the next class, I'm going to start with frequency of the sound wave in detail. So like we will be discussing on what exactly the frequency of sound is. Then we'll discuss on the time period of the sound wave. Then we have amplitude of the sound wave. Okay. Then after amplitude, we have pitch and loudness of the sound to discuss. Then we have speed of sound in different mediums, reflection of sound to discuss. Okay. Then we have echo, reverberation to discuss in detail. After that, we even have uses of multiple reflection of sound to discuss. Okay, so we will be discussing on all of them in detail, and after that, we will be even discussing the range of hearing. Okay, then after discussing the range of hearing, we'll be discussing on uses of ultrasonic sound in detail. Okay. After discussing the uses of ultrasonic sound, we will be discussing on sonar in detail. Okay, so these are all important concept which comes when we discuss more about human ears and all. Okay. Then after that we will be discussing on structure of human ear, and at the end we have the summary discussion for the whole lesson that we will be doing. Okay, and after the summary discussion we have like 22 questions to discuss. At the end we will be discussing on those 22 questions as well. Okay, so I'm going to show you the questions one by one. I want each one of you to please go through these questions, okay? Because you are the one who are going to like answer them all at the end. So please make sure that you know the question and you are able to answer it as well. Okay? See, you will be able to answer them once we like study about the concepts of sonar and all, but still like this kind of questions are there that you need to calculate the speed of sound in water and all. So make sure you know it. And the last question is explain how defects in a metal block can be detected using an ultrasound. So once we discuss on it, like you'll be able to answer them all. And last question that we have is explain how the human ear works, right? So we'll be discussing on all this, and this is how we are going to end up with the lesson sound. And I hope that whatever we have discussed in this part for the lesson sound, each one of you are clear with it. Now the rest of the part for the lesson I'm going to continue in the next part. Thank you everyone.